Algebra 1, Lesson 27, identifying misleading representations of data. So a lot of what we're looking at today is looking at graphs and determining what is misleading about a graph, how it's misleading us, what it's misleading us to think, and how we can correct those graphs to make the information a little bit more fair in its representation. So when displaying data, components such as the scale or the labels can make a graph misleading. So those are two things that we want to look at. Okay, look at the scale. Is the scale misleading? Are the labels on the graph misleading? Another characterization that may create a misleading graph is the size of the increments in the scale, right? Are we going by halves? Are we going by 50s? Are we going by 1? You know, and we will look at that in relation to the labels and see why might that be a misleading factor, okay? Because what's misleading in one graph may not be misleading in another graph. And that is the extent of the unique notes that they hand you. All right, so we're going to look in here, and we're going to get started on some questions. Now, question number 1 says the line graph represents the price of a type of personal computer over a 5-year period. Explain why the graph may be misleading. Okay? So I want you to look at it here for a second. See if you can tell why it might be misleading. Yeah. It does start at 0. Yeah, I mean we'll always assume that it starts at 0. But you're not knocking on the door. You're just not there. You're looking in the right place. Caden? Right. So our price increments are not the same. So from like 0 to 800, it's going up by 800, and then it goes from 800 to 1600, right, which is going up by 800. So it should continue to go up by 800, right? Right, which the next spot would be what, 2400? But then it only goes up, what, 200? And then it only goes up 100. And it only goes up 100. So it looks, right, if we look from 2002 to 2003, it looks like it's dropping a whole bunch in price, doesn't it? But how far has it actually dropped? It's only dropped $200, right? And then it looks like, okay, well, it's not dropping off very much between 2003 and 2004, but it's actually dropped the same amount, hasn't it? And then it looks like, oh man, it's really petering off between 2004 and 2005, right? Prices aren't really dropping that much, but we can't even hardly tell because there's a difference of $800 here. This might still be 200 and 200 again. But do you see how the graph is misleading, right? It's leading us to think that from one year to another year, there was a big sharp change and that it had less of a change over time, when in fact, it's pretty well linear, right? So our answer, can anybody tell what the answer might be in here? If I erase some of this. All right, A, the graph is misleading because the vertical axis does not start at 0. That may or may not be. Some might believe that the price change from 2004 to 2005 was the same as the change from 2005 to 2006. In fact, the price change was much different. Actually, it wasn't much different. Okay. B, the graph is misleading because not enough years are shown. Well, that's not really a problem. Some might believe that the price of the computers have decreased over time. In fact, if the graph had included the years before 2002, it would show an increase, then a decrease. Well, we don't know that. Right? We don't have enough data to prove that. Okay. C, the graph is misleading because the intervals on the vertical axis are not equal. Right? Didn't we see that? Someone might believe that the price declined quickly from 2002 to 2004, then more slowly. In fact, the price declined $200 each year. Okay. And so C is what we want to go with, but let's look and see what's wrong with D. The graph is misleading because a line graph is not a good way to show trends. Well, it's a fine way to show trends. Right? We can show trends in a lot of different ways. Someone might believe that the computer price has declined significantly over the past 5 years. In fact, the price has stayed almost the same. Well, that's not true. Otherwise, it would be straight across, correct? Despite whatever the change problems are. Okay, so are we seeing how to look at graphs and what kinds of things we want to look for? All right, let's keep going here and let's see if we can find some more. All right. 2, both bar graphs show the weights of 4 bags of rice. Which graph could be misleading? Okay. We have weights. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 seems okay. Are scales and weight the same? Yes or no? Yeah? Okay. We have 4 bags on either side. Okay. Tiffany. The bars have different thicknesses. And do those thicknesses appear to represent anything? But what might they lead us to believe? Right, that bag 4 weighs more because it has a bigger area, right? When the real data that we want to look at is how high up on the line does the bar go, right? Because it's the height of the bar that represents the weight, not the width of the bar that represents the weight, right? Not the area of the bar that represents the weight. Okay, good. You guys, good observation there. Okay, let's see. So we think that graph A is misleading. Graph A could be misleading. The height of the bar for bag 4 is too short. It appears that all the other bags weigh more than bag 4, so that was B. But graph A could be misleading. The width of the bars of the bar graph are not uniform. It appears that bag 4 weighs more than bag 1, even though in reality it doesn't. Just because bag 1 is a skinnier bar doesn't mean that it weighs less. Okay? That's also true of people, by the way. People's weight is misleading based upon height. Like, I weigh almost 200 pounds. I don't look like I weigh 200 pounds because I'm tall and skinny. So there you go. All right, the circle graph shows how the average American family spends its money. Explain why the graph may be misleading. Caden's got an idea. Caden, what do you think? Right. Yeah. Does it appear that the percentages actually represent what should the total percentage actually come up to, though? It should be 100%, right? So, I mean, what's our total? Let's go ahead and add it up. We've got 6, 15, 31, and 18, right? We got what, 9 and 11, so that's what, 20? All right, so there's 2, 3, 6. That only represents 70%, right? So there's not 100% represented here. So yeah, 31% is almost half of 70, right? If we got the 35. So yeah, we're not representing a whole here, and a pie chart should represent 100%, right? Okay. So is A the part of this that's misleading? No? Okay. You think it's B? Okay. The sections of the graph do not add up to 100%, so the percent for at least one type of expense is not represented. That's possibly true. Some people might believe that transportation is a major expense. Well, it is for some people and it isn't for others. The amount of money spent on transportation and food exceeds the amount of money spent on housing. Well, it could, right? Different people spend different amounts of money on different things. So none of those things are misleading, but what is misleading is the fact that we don't have 100% representation. Okay. All right. In a survey, let's see, what time do you get out of here? I just want to make sure that I don't keep you. 31. 31. So let's answer this question and I'll let you go. Okay. In a survey, participants were asked to choose their favorite of 4 cereals. We got Health Grain Cereal Company made the graph below to display the results of the survey. Okay. So notice here, whenever they have a break like this, it means that it does start at 100, but the scale from 0 to 65 is not going to be the scale that we use once we get to 65. Okay, so it, just a way of, so I kind of can keep my graph a little bit shorter. Okay, they want to explain want you to explain why the graph may be misleading, what conclusion might be made from the graph, and why health grain have created this graph. Well, you don't really want people whose data is on the graph to actually make the graph, right? So that's misleading right off the bat. But go ahead.
There's 4 cereals and you can't tell which one's which.
Right. They say health grain is this one, but we don't know what A, B, and C are. Now, we do have that this fact that this scale does not start at 0, so the heights of the bars vary greatly, even though the data values are very close to each other. You know, look, we got 90 and 85. That's actually pretty close. 80, you know, even down here, 65 is really not that far away. We really don't know. I mean, this is just participants, but the difference between 65 people saying brand A and 90 people saying health grain is really not that far from each other, right? But it looks like that because we didn't start at 0. Okay? Let's see. What conclusions might be made from the graph? Well, we might assume that more people like health grain, right? Okay? Let's see. And so this would be better if we had gone by, started at 0 and maybe gone by 20s, right? And that would have put our bars a lot closer to each other. Okay, does that make sense? So we could redraw that and just put in an actual scale rather than having this jump and then going by 5s. Okay, all right, we'll stop there. Your assignment is A through F, 1 through 10. Okay, I think that's only about 16 questions.